Morning, everybody. Today we're going to continue our talk on compound inequalities, but today we're talking about compound inequalities. So, what compound inequalities mean? A compound is anything that is two or more. So we're going to be using two or more inequalities for the same problem today. How we do that is we can start by graphing two separate inequalities. Right here we have x is greater than -5, so we can graph that on our number line. It's an open circle because we don't have the line underneath it, so I'm going to put it right over here because eventually we're going to have something else over here. So -5, and our arrow is pointing to the right. We draw an arrow to the right. Down here we have x is less than or equal to 0. So we're going to draw a closed circle. That's going to be 0. And now our arrow is pointing to the left. So draw an arrow to the left. Now down here we have both of these inequalities, but they are put into one problem. So here's our first one. And here's our second one. So both of these inequalities are now part of one problem. This one is okay to graph, so we can graph that down there. This one, if we rewrite it, comes out to be -5 is less than x. Now our variable is on the right, so we need to get it on the left, so it's x is greater than -5. So now this one's good to graph, so this can come down here. So x is greater than -5, open circle, -5, and our arrow is pointing this way. And then over here, we have x is less than or equal to 0, closed circle, 0, and our arrow is pointing here. So now what this is saying is that x can be anything in between -5 and 0. We show our and inequalities by these symbols. We can draw an arrow between both of these. So this symbol shows that we're going to have two arrows meeting in the middle. On our next problem, we have x is greater than 23. So this is going to be an open circle. Pointing to the right. And this is going to be an open circle. X is less than 19 is an open circle pointing to the left. Now we can graph these both just like this. We have x is less than 19, so we can put an open circle here to the left. This is 19, and x is greater than 23. So an open circle, 23, pointing to the right. What we have here are OR inequalities, so OR problems. Over here we have AND, this is now OR. So if we're to show it on our hands, we'd have an arrow pointing this way, and an arrow pointing this way. Just like we have here, an arrow pointing to the left and an arrow pointing to the right. Here we have to write an inequality that is represented by the graph. So we have two arrows pointing towards the middle, so we have an AND inequality. So we can start with this first one. Or how about let's start with this one. So we know that we have x is less than or equal to 3, because we have a closed circle. And we know we have x is greater than -2, because we have an open circle here. Now how we would write this in our AND inequality is we would start with the smaller number, so -2, flip the sign, so now we have x in the middle. Then we can just write this as the same down here. So is less than or equal to 3. So we have one problem right here. And the other problem is right here. This would be our AND inequality. -2 is less than x, which is less than or equal to 3. So the answer for x could be anything in between 3 and -2. Here, let's write out our separate ones first. So we have x, our arrow's pointing to the left, so we can draw an arrow to the left, is less than 0, and x, our arrow's pointing to the right, so we point an arrow to the right, greater than or equal to 2. Now this is an OR inequality because we have arrows pointing in different directions. So all you need to write then is OR between them. So x is less than 0 or x is greater than or equal to 2. Here we need to sketch a graph of this inequality. So we have x is less than 8. So we can draw an open circle there, and this will be 8. Our arrow for this problem is pointing to the left, so we draw an arrow to the left. This is an OR inequality, so we know we're going to have two arrows pointing different directions. Then we have an open circle of 15, and our arrow here is pointing to the right, so we draw an arrow to the right. So two open circles, but they're pointing opposite directions, just like our OR says. Here we can separate these into two problems. One there, and one here. So what we have is -4 is less than x, and x is less than 2. Now the problem with this is that our variable is on the right, so we need to get it to the left by flipping it. So x is now greater than -4. This one is just fine to graph. So -4 is the smaller one, so we start on this side where the smaller numbers would be on our graph. And we have a greater than sign, so an open circle. This would be -4 with an arrow pointing to the right. Arrow pointing to the right. Here we have x is less than 2 with an arrow pointing to the left. So we draw another open circle because it's less than 2 with our arrow pointing to the left. Now both of our arrows are touching, so that makes this an AND inequality. That means that x can be anything between -4 and 2. Here we need to solve the inequality and graph our solution. So now we're adding some number in between here. How we do this is we draw two lines straight down from our inequalities. And we need to get x by itself. So how to get x by itself is we need to do the opposite of 3, or plus 3. So we're going to subtract 3. Now because we have numbers on both sides of our inequality, or our problem, we need to do this to both sides. So -3 here, and -3 here. So now those cancel. What we're left with in the middle is x. -4 minus 3 is -7. 11 minus 3 is 8. So now we keep our symbols. So now we have -7 is less than x, which is less than 8. So how we would rewrite that is -7 is less than x, and x is less than 8. This one we need to flip around to get the x on the left side. So we have x is now greater than -7. And to graph this, we can make our number line. Okay, so we have x is greater than -7, so our -7 is going to come over here. It's going to be an open circle because it's greater than, not greater than or equal to. So -7 with our arrow pointing to the right. And x is less than 8. So it's going to be another open circle because it's less than 8, which is pointing to the right. Or the left, sorry. So two arrows meeting each other, so this is an AND inequality. This would solve our inequality up here because these two are pointing to the middle. We have some x in the middle. Over here, we have two separate problems that we need to solve. First one, we need to subtract 3. First of all, let's make a little squiggle in here to separate the two problems. First one, we need to subtract 3. Solve this. So we get 2x is less than 9 minus 3, which is 6. Divide by 2 to get x by itself. And we're left with x is less than 3. Over here, we need to add 6. Remove that 6. What we're left with is 3x is greater than 12 plus 6, which is 18, divided by 3. So x is greater than 6. So here are our two inequalities that we need to graph. So if we draw a number line down here, we can start with the smaller number. So x is less than 3. So we draw an open circle. And our arrow is pointing to the left. So we draw an arrow to the left. This is an OR inequality, so we should have these arrows pointing in the opposite directions. Here x is greater than 6, so another open circle pointing to the right now. And this is 6. So we had arrows pointing in opposite directions, which we know we should have because we have this OR inequality. Here we have to solve the inequalities again, then graph them. So we have an AND inequality, so we're going to draw a line down from both of them. What we have to do is we need to do everything in the middle and then put it onto both sides. So the first thing we have to do is subtract 4. Subtract 4 on this side and subtract 4 on this side. What we have left is 10 minus 4, which is 6, is less than or equal to negative 2y, which is less than or equal to 20. So now to get y by itself, we have to divide by negative 2. What we do in the middle, we have to do to both sides. So divided by negative 2 and divided by negative 2. Y is now by itself. What we have left is 6 divided by negative 2, which is negative 3, is less than or equal to y. 20 divided by negative 2 is negative 10, which is less than or y is less than or equal to negative 10. So now how we would graph this, well, first of all, let's rewrite these problems. So if we rewrite this problem, we would have negative 3 is less than or equal to y. Y needs to be on the left, so we need to flip it. Y is greater than or equal to negative 3. Here we can write this problem out. We have y is less than or equal to negative 10. Now if you notice up here, we divided something by a negative number. So negative 2, we divided both sides. So what that means is we need to take our signs and we need to flip them. So one last time we need to flip this. Y is now going to be less than or equal to negative 3. And y is now going to be greater than or equal to negative 10. So we can cross these out. We don't need those anymore. We did this because we divided by a negative number, or a negative 2. And remember, the rule is when you're multiplying or dividing by a negative number, you need to flip the sign. So we can draw our number line. Our lowest number is negative 10. So we need to draw a closed circle on the lower than or less than side. This would be negative 10. And our arrow is now going to be pointing to the right. Over here we have y is less than or equal to negative 3. Negative 3 is greater than negative 10, so we have an open circle farther up on the number line. And our arrow is now pointing to the left. So we draw an arrow to the left. And these arrows will meet, which makes our equation, our inequality an and inequality, which we figured out was because they don't have the or in between and there's numbers meeting in the middle. Over here, we need to solve both of these inequalities. So we're going to subtract 1 on this side. Let's draw a little squiggle between them so we can separate the problems. So we have 3h is less than negative 5 minus 1, which is negative 6. And divide this by 3. Divide this by 3. H is now less than negative 2. Over here, we need to add 5. And add 5 here. Those will cancel out. We get 2y, or 2h, sorry, is greater than 7 plus 5, which is 12, divided by 2, divided by 2. H is now greater than 6. To graph this on our number line, we got to make a number line. Start with a smaller number. H is less than negative 2. So it's an open circle because it's less than, pointing to the left. And H is greater than 6. So an open circle, 6 is pointing to the right. So this is our OR inequality. We know that because we have numbers pointing in opposite directions. What that means is that H can be anything that is less than negative 2 or greater than 6. Cannot be anything in the middle here between them. Alright, a couple more. Here, we have an OR inequality, so we need to solve each side. So we need to subtract 3 from this side. So subtract 3 here. Those will cancel out. We get 2r is less than 7 minus 3, which is 4. Divide by 2. And divide by 2. R is now less than 4 divided by 2, which is 2. Here we need to subtract 9. So subtract 9 from both sides. And subtract 9 from this side. What we're left with is negative r is less than or equal to 2 minus 9, which is negative 7. Now, if we just have an r, we can put a 1 in between them. So now we have a negative 1r is less than or equal to negative 7. We need to get r by itself by dividing by negative 1. And divide by negative 1 over here. we get r. We divided by a negative number, so we need to flip the sign. Negative 7 divided by negative 1 is positive 7. To graph that on our number line, let's make a number line here, down at the bottom. Graph the smaller number first. So we have r is less than 2, so an open circle, 2 pointing to the left, and r is greater than or equal to 7, so closed circle, 7 pointing to the right. So our OR inequality is now pointing to both directions, 2 and 7. So less than 2, greater than or equal to 7. Alright, this last problem, we need to make this is an AND inequality, so we need to make it into two problems. We can draw a line down from both of these. Now what we have in the middle is 2 times w plus 8 in parentheses. So when we have parentheses, we know we can draw our box. What we have out front is 2. What we have on top is w plus 8. So 2 times w is 2w. 2 times 8 is 16. So what we get is 2w plus 16. So now we need to get w by itself here. So we need to subtract 16 from both sides. So subtract 16 up here, and subtract 16 over here. So negative 14 minus 16 is negative 30. Negative 30 is less than or equal to 2w. Six minus 16 is negative 10. So 2w is now less than negative 10. So to get w by itself, we need to divide by 2. That means we have to divide everything by 2. So what we have left is negative 30 divided by 2, which is negative 15. Is less than or equal to w, which is greater than negative 10 divided by 2, which is negative 5. If we rewrite this problem, we rewrite this one here, we would have negative 15 is less than or equal to w, but we need the variable on the left, so we would have w is greater than or equal to negative 15. Over here, we would have w is less than negative 5. So now we have our two problems. We can graph it on our number line. So let's create a number line. Let's start with the smaller one. So w is greater than or equal to negative 15. So a closed circle that's greater than or equal to negative 15. pointing to the right, and W is less than -5. It's an open circle because it's less than, pointing to the left. Our inequalities should meet, which gives us an AND inequality, which that's what it was up at the top. So we know we did this correctly. Alright, thanks for listening. If you have any questions, be sure to ask. Go grab your homework and have a great day. Thank you.